Hey, imagine machine learning as a super smart party planner that's popping up everywhere, helping decide who gets loans, who gets hired, or even who might need extra attention from the police. But here's the catch. If the info this planner uses is biased, like a guest list that unfairly favors one group over another, the decisions can end up unfair, too. For example, it might say no to someone's loan just because of their background, like race or gender. Let's dive into how we can make this party planner fairer, using some cool tools and tricks from a research article I came across. What's fairness all about? Fairness is all about treating everyone equally, no matter who they are. In machine learning, it means making sure the system's choices, say, who gets a loan or a job, don't unfairly depend on things like race, gender, or other personal traits. It's not just about building a smart system, it's also about making sure people can understand and challenge its decisions. If the system's like a black box nobody can peek into, that can feel unfair, too. Why fairness is a big deal. Picture this. The data we feed our party planner is like a recipe book from the past. If that book has biased recipes, like only serving chocolate cake to certain folks, it'll keep making unfair choices. For instance, a loan approval system might turn down people from one group more often if the old data shows biased lending patterns. The researchers explain that fairness in machine learning is about stopping these systems from picking up and repeating those biases, so everyone gets a fair shot. 3 ways to make things fair. The researchers talk about 3 main ways to throw a fairer party with machine learning. 1. Prepping the guest list, pre-processing. Before the party starts, we clean up the guest list to remove any unfair biases. It's like making sure everyone's invited based on their love for desserts, not their background. This cleaned-up list can then be used by any party planning system to make fair choices. 2. Guiding the planner. In processing, while the system is making decisions, we give it rules to follow, like don't pick favorites based on where people are from. Some planners get these rules by balancing priorities, like planning a great party while avoiding unfair choices, or by using clever tricks to make sure the system can't guess someone's background from the data. 3. Fixing the party favors. Post-processing. After the system picks who gets what, we can tweak the results to make them fairer. It's like rearranging the dessert table so everyone gets an equally tasty treat, no matter what group they're in. These tweaks can even help create fair guest lists for future parties. Most of the time, these methods focus on making one party fair, but the researchers say we need to think bigger, making sure the system stays fair for lots of different parties, like hiring, promotions, or loan approvals. The dessert party trick, Wasserstein-2 Geodesic. One cool tool the researchers share is like planning the ultimate dessert party, where everyone's sweets taste equally awesome. Imagine you've got guests bringing their favorite desserts, cakes, pies, you name it. Your job is to mix these desserts so everyone enjoys the same yummy vibe. Here's how it works. Start with the guest list. You've got a list of guests, each in a group, like cake fans or pie lovers, with details about them and a score from your party app saying how much they'll love their dessert. You also pick a number of taste test categories, say, 5 levels of sweetness, and a blend knob to mix group flavors with a crowd favorite. Group the guests, sort everyone into groups based on their dessert type, and figure out an average dessert that captures the whole party's taste. Rank the desserts. Taste each group's desserts and rank them from least to most delicious. You find the score where, say, only a fifth of the cakes are less sweet than the rest. Flip the ranking. Now, for any dessert score, figure out where it ranks in the group. Like, is a sweetness of 7 a top-tier cake or just average? Blend the flavors. Use your blend knob to mix each group's rankings with the crowd's favorite flavor. If the knob's set to keep more of the group's taste, you lean on their rankings. If it's turned toward the average, you mix in more of the crowd's flavor. It's like blending chocolate cake with a hint of vanilla for balance. Get new rankings. Check where these blended flavors rank on your sweetness scale. Each group gets new scores that balance their unique taste with the party's overall vibe. This dessert blending trick ensures everyone's dessert scores are fair, matching the crowd's tastes so no group feels left out. It's a way to tweak the system's outputs to treat all groups equally, no matter the decision cutoff. The Music Festival Map, Causal Bayesian Networks. Another awesome tool is like a map for a music festival, helping you make sure everyone gets a fair spot near the stage. Imagine you're the festival organizer, and you don't want anyone pushed to the back just because of their hometown, or stand-in for traits like race or gender. This map, called a Causal Bayesian Network, shows how things like hometown, music taste, and arrival time connect to decide who gets what spot. The map shows connections. Your map has arrows showing how one thing leads to another. Maybe hometown influences music taste. City folks love rock, coastal folks dig reggae, and music taste affects when people arrive. Rock fans show up early. Reggae fans stroll in late. Arrival time then decides their spot. The map lays it out. Hometown music taste arrival time spot. Spotting unfair paths. You notice something's off. Some coastal folks get worse spots just because of their hometown, even if they arrived early. It's like security saying, "Coast people, to the back." This is an unfair path on your map, where hometown wrongly sways the spot. Measuring unfairness. The map helps you figure out how bad this unfairness is. You can ask, if we ignored hometown and only looked at arrival time, would this person have gotten a front row spot? It's like imagining a world where coastal folks were treated like city folks to see if it changes their spot. Fixing the festival. To make things fair, you tell security, only check arrival time and music taste, not hometown. This tweaks the system to block unfair paths, ensuring spots are assigned fairly based on things that should matter, like when someone showed up. Why the map rocks. This festival map is a game changer because it clearly shows where unfairness sneaks in and helps you fix it. Without it, you might miss that hometown is causing trouble. The researchers love these maps because they're intuitive and powerful, helping spot and fix complex unfairness, like in a tool that predicts crime risk. Think of these maps as your festival DJ, mixing tracks, like data factors, to create a vibe where everyone enjoys the show equally. If one group's music is too loud, the map shows you how to balance the playlist for fairness. A one-size-fits-all plan. Instead of having a bunch of different fairness fixes for every situation, the researchers suggest a single, flexible plan that works for all kinds of tasks, like predicting numbers or categories. It's like having one awesome party planning guide that works for any event, with promises it'll keep things fair and reliable. Keeping fairness across many parties. Sometimes, you want your party planner to be fair not just for one event but for lots, like planning both a hiring party and a promotion party. The researchers share a way to create fair building blocks that stay fair even when reused for new events, so biases don't creep back in. Playing by the rules. Some laws say you can't use info like someone's hometown when planning the party. The researchers have a trick to train the system to be fair without needing that info when it's time to make decisions, keeping things legal and fair. Wrapping it up. Making machine learning fair is like throwing a party where everyone feels welcome and gets an equal share of the fun. Whether it's blending desserts to match everyone's tastes, using a festival map to spot unfair treatment, or creating a plan that works for all kinds of events. These tools help ensure our smart systems make fair choices. The researchers call for more work to keep improving how we make machine learning a good citizen in the real world.